Welcome back. In this explainer, we're going to tackle a really core idea about how science works. We're going to ask a pretty radical question. What if scientific progress isn't about getting closer and closer to the truth, but about changing the world entirely?
All right, let's just dive right in. First up, the myth of scientific progress. We're going to start by poking holes in a very common, very intuitive idea about how science actually moves forward.
Most of us have this picture in our heads of how science works. It's like building a big wall of knowledge, right? Every new discovery is just another brick we add on top of the old ones, and the wall just gets taller and stronger. It's a nice, neat, cumulative process. And the classic example everyone uses is the jump from Newton to Einstein. The usual story is that Einstein just fixed Newton's work. He swapped out a pretty good brick for a perfect one that works better when things are moving super fast. But is that really what happened? Was it just a simple correction? Let's really dig into that famous transition, because according to the philosopher of science, Thomas Kuhn, this wasn't just a simple fix at all. No, it was a full-blown revolution that put Newton and Einstein, worlds apart. So here's the absolute core of Kuhn's argument. He says you can't actually get Newton's laws from Einstein's theory. Now, you can make Einstein's equations look like Newton's if you pretend speeds are really low, sure. But to do that, you have to completely change what the most basic things in the universe, like space, time, and matter, even mean. And this slide just nails the problem perfectly, using just one concept, mass. For Newton, on the left, mass was simple. It's just the amount of stuff in an object. It's fixed. It doesn't change. But in Einstein's world, over on the right, mass is a totally different beast. It's relative, and it's actually a form of energy. Remember E equals mc squared? That's what we're talking about. And this is the crucial point, so you really got to get this. Even though Newton and Einstein both used the same words, space, time, mass, they were talking about completely different things. They were operating in fundamentally different universes, conceptually speaking. Newtonian mass can't become energy, Einsteinian mass can. They are just not the same thing at all. This all leads to Kuhn's most famous and radical idea, incommensurability. It basically means you can't measure two different scientific paradigms with the same ruler. It's impossible. They're playing by different rules, they're made of different stuff, they're even trying to answer different questions. They are, in a word, incommensurable. So what this means is that a paradigm shift, a scientific revolution, isn't just about a new discovery. No, it's about fundamentally changing the rules of the game. You're not just playing the game differently, you're tearing up the old rulebook and writing a brand new one. And you can see this incredible domino effect right here. It all starts at step one. Your entire view of what the universe is fundamentally made of changes. That kicks off step two. The list of problems that science even bothers to solve gets totally rewritten. And that leads right to step three. The very definition of what counts as a good scientific answer gets turned on its head. Let's jump back in time for another great example. Think about the 17th century. Science went through this massive shift from a world that was explained by the innate qualities of things to a world that was seen as just a giant machine made of tiny little particles bouncing off each other. Before this revolution, you could say a stone falls because it's in its nature to fall. It has a tendency to go down, and that was a perfectly good scientific explanation. But after the revolution, a scientist like Newton would have laughed at that. He'd say, that's not science. The only real explanation has to involve particles and forces and motion. The very idea of what a cause is had completely changed. And this all leads to a really startling idea. These scientific revolutions don't just add new knowledge. Sometimes they cause old knowledge, old problems, even entire fields of science, to be completely lost or just abandoned. So a new paradigm doesn't just come along and solve old problems in a new, clever way. A lot of the time, it just declares that those old problems were never real problems to begin with. They were pseudo-problems, just meaningless questions based on a totally wrong view of the world. This table has some fantastic examples. That old question about innate qualities, thrown out, declared unscientific. And then there's the ether. For about a century, physicists were obsessed with finding this invisible stuff that light was supposed to travel through. But the problem wasn't solved, it was dissolved. Einstein's new way of thinking just showed the ether didn't even need to exist. Poof, gone. And how about gravity? This one is wild. For Newton's followers, explaining what caused gravity was a huge problem. Eventually, they kind of gave up and just accepted it as a built-in feature of the universe. But then, centuries later, Einstein comes along and makes that question the absolute center of physics again, but in a completely new way, framing it as the curvature of space-time.
So, what does this all add up to? Let's bring it all together for the final and, frankly, the most mind-bending takeaway from all of this.
This is the biggest idea of all. Right here. Kuhn's point is that after our revolution, scientists don't just see the world differently. They are, in a very real way, working in a different world. The things they're looking at, the tools they're using, even the laws they observe, have all been fundamentally transformed. So, in the end, a paradigm is so much more than just a theory. It's the whole operating system for science. It provides the map of reality, it gives you the tools to explore it, and it even tells you what destination you should be trying to reach.
And all of this leaves us with a final, massive, and kinda unsettling question. If every scientific revolution put scientists into a new world, what does that do to the comforting idea that we're slowly but surely getting closer to the one final truth? It forces us to ask, what paradigm, what world are we living in right now? And what unseen revolution is waiting just around the corner to change it all over again?